Good evening, dear students. So we are classification of elements and periodicity. So this is the third chapter. Yes, from your PU1. So we have seen some of the important notes in the previous class, synopsis, right? And we have seen some of the important things in our last class. So today we are going to continue with the same. Okay. So shall we start? Yes, so students are joining now. Okay, so I will start the class now. Fine. So in the last class, we were discussing about the classification of element in properties. Okay, so how are the elements? We cannot, so there are 118 elements in the periodic table. So it is very difficult to study each element separately. We are studying it in the different blocks, okay, in different groups. That is S block, P block, D block, and F block elements, right? So based on that, so there were different scientists, okay. So according to their different laws were put forth. So that all things we have discussed, okay, how the rows, what were periods, what were columns, okay. So these all things we have discussed in our previous class. Then we have discussed about the general configuration of S block, P block, D and F block elements. So these all things we have discussed in our previous class. Okay. Then periodic properties, right? We had started with the periodic properties. So which are the different periodic properties? We had started with the atomic radius, ionic radius, okay, covalent radius, van der Waals radius. So these all things we have discussed in our previous class. Okay, then I had just started with ionization potential or ionization energy. Now, what do you mean by ionization potential or ionization energy? It is the minimum amount of energy, okay, which is required to remove an electron from an isolated gaseous atom. Okay, so very important concept. Okay, so always the first ionization energy is less than that of the second ionization energy. Okay, so when we are removing the second electron, so that time the energy which is required, okay, to remove that electron will be more. The energy required will be more. So always the successive, okay, what we say, the successive ionization enthalpy will be more. Okay, so if you are removing first electron, the energy will be more. But when you are removing the second electron, that times the second. So as you are removing the next electron, okay, so the successive electron, when you are removing the successive means the next electron, like that. So that time the energy will be higher. Okay, so IE3 will be greater than IE2, which is greater than IE1. Okay, like that. So successive ionization potential energy will be more. Okay, so now so what are the different factors? Okay, what are the different factors which are affecting the ionization energy? The first one is size. Okay, size of the atom. So if the size of the atom is larger, then less amount of ionization energy is required. Okay, so first point, size of the atom. If larger the atomic radius, okay, what is atomic radius? It is at half the distance between the nucleus and the first electron. Okay, so larger the atomic radius, as how much the larger atomic radius, smaller will be the energy, ionization energy required, because the force of attraction will be more. Okay, force of attraction will be less here, because the electron and the nucleus, okay, it will be more. So as the radius is larger, what will happen to this force? The force of attraction to remove the electron will be less. Okay, the energy required to put that to remove that electron will be less. So larger the size, smaller will be the ionization energy. So this is the first factor, very important factor. Okay, Next important concept is, what? It is a electron affinity. Okay, what do you mean by electron affinity? Electron affinity means it is the energy which is released. Okay, the energy which is released when you are adding up one extra electron. So when you are adding one extra electron, okay, to then neutral gaseous atom to form an anion is called as electron affinity. Okay, so when you are adding an electron, ionization enthalpy is different and electron affinity is different. Okay, electron affinity means what? It is the energy which is released when you are adding an okay, so when you are adding up an extra electron, okay, to the neutral gaseous atom, it is called as electron affinity. Suppose chlorine, okay, chlorine, it is 17. So if I write the electronic configuration, it is 1s2, 2s2, 2p6, 3s2, and 3p5. Okay, so it requires one electron so that its octet is complete. Octet means what? When you have 8 electrons in the outermost shell, okay, it is called as octet. And always octet, whenever it is having an octet, completely filled octet, it is said to be stable. Okay, we know this. So now chlorine, as the atomic number is 17. So when we write the electronic configuration, it is 1s2, 2s2, 2p6, 3s2, and 3p5. So it requires one extra electron to be more stable. Okay, so what the chlorine will do? Chlorine will accept one electron. Okay, it will accept one electron and it becomes Cl minus. So it becomes what? It becomes chloride ion. Okay, it becomes chloride ion. Okay, it is a N ion. N ion. When you have a negative charge, okay, on the atom, it is said to be what? It is called as N ion. Okay. And when you have a positive charge on an element, it is called as cation. Right. So we have seen that in the case of ionization potential. Now electron affinity, it is taking upon extra electron. So that energy which is released, okay, it is called as the electron affinity. So remember this very important concepts. Next is electron negativity. Okay, next is electronegativity. What is electronegativity? Now, suppose I have hydrogen chloride. Okay, I have hydrogen chloride. Now, chlorine. What is a chlorine? Chlorine is a halogen. It belongs to what? It belongs to halogen group. Okay, halogen. So, it belongs to group 17, that is halogen family. It is called as what? Chlorine. So chlorine is what? Chlorine is a highly electronegative atom. Now, what is the role of this highly electronegative atom? It tends to attract the electron towards itself, right? You know this? So electronegativity, it is highly electronegative. So what it is doing? It will try to attract the electron. Now, between the your hydrogen and chlorine, a pair of electron is shared, right? A pair of electrons is shared between these two atoms. Okay. Now, what this chlorine wants to do? This chlorine wants to extract the electron towards itself. Okay. The chlorine, what it wants to do? It wants to attract the electron towards itself. So, as a result, there will be partial negative charge on chlorine and partial positive charge on the hydrogen atom. Okay. So, because of this, there will be what? Electronegativity. So what is electronegativity? It is a tendency. So what is electronegativity? It is the tendency of an atom to attract the shared pair of electron. Now here, which is electronegative? Our chlorine. I hope this is clear. So which is our electronegative atom here? Chlorine. So what it is trying to do? It is trying to attract the electron towards itself. Okay. So this is termed to be the electronegativity of an atom. Okay. So when we are talking about electronegativity, so the trend, okay, so it will vary across the period and down the group. So as you are going across the period, okay, what will happen to electronegativity? It will increase from left to right. Okay, it increases. So it increases when you move across the period. And when you go down the group, okay, what will happen to electronegativity? It decreases. Okay, what happens? It decreases. So remember these 2 points, very important points. Okay. Next is valency. Now, what do you mean by valency, students? Okay, what do you mean by valency? Valency is the combining capacity of an element. Okay, how the element will combine. Okay, so that is explained in terms of valency. Okay, so the number of electrons present in the outermost shell of the atom, which are required for bonding. So now, suppose oxygen. So 1s2, 2s2, 2s2 and 2p4. So how many electrons are there? 4 electrons are there, right? Now here, out of 4, 2 electrons, okay. So 2 electrons are what? There are two unshelled pair of electrons. So here the valency of the this is -2. Okay, so it has a tendency to give 2 electrons. So now carbon has 4 electrons. Okay, 1s2, 2s2, 2p2. So 4 electron in its outermost shell. So so what is that? It is the combining capacity of an element. Okay, so which is explained in terms of valency. So this valency, it will be from depending upon the number of electrons which are present. Okay, so just let us see. So how the valency of the element, it increases from hydrogen, okay, so to 1 to 4, okay, and then decreases in the period. So and when we go down the group, what will happen? The valency will remain the same. Okay, in the same group, the valency will be same. Okay, in the group, the valency, it is having the same valency. But when you are moving across the period, so first it will go from 1 to 4. Okay, and then from 4 to 1. So the valency goes on, increases and then decreases. So this is about valency. So remember, what is valency? It is the combining capacity of an element. Okay, fine. Now let us sum up. Okay, oxidation state. Okay, one more thing, oxidation state or oxidation number. It is the total number of electrons. Okay, it appears to have gained or lost during the formation of a particular compound. Okay, oxidation state. Now suppose Na plus. Na plus, okay, means what? It has lost plus 1 electron. So plus means what? There is a loss of 1 electron. Now Al plus 3. Okay, so this plus 3 tells you the oxidation state of that element, or it tells you the oxidation number of the element. How many electrons are lost? So there are loss of 3 electrons. Okay, suppose same way with respect to sulfide S2 minus. Okay, so there is what? There is a gain of 2 electron. Okay, minus means gain and plus means loss. Okay, so oxidation state, it tells you how many electrons, total number of electrons are lost or gained. So remember this. Okay, so last we will just brief this. Okay, so how this property varies? So atomic radius in the group, okay, that is from top to bottom, it increases. Okay, as you go from top to bottom, it increases. As you go in the period, okay, it decreases. So remember this, very important. Okay, atomic radius. Next is ionization energy. From top to bottom, it decreases. Okay, and across the period, it increases. Then electron affinity, same, it decreases, and in the period, it increases. Electronegativity in the group, it decreases. Okay, that is from top to bottom, it decreases, and across the period, it increases. Then electropositivity, it tells you the metallic character. Okay, it tells you the metallic character of an element. Okay, how electropositive it is. Okay, so it will be reverse of electronegativity. So across the group, it will increase, and across the period, it will decrease. Okay. Then the oxidizing power in the group, it decreases. In the period, it increases. So this trend is very important. Please remember this. Okay. Please note it down. And reducing power across in the group, it increases, and across the period, it decreases. Okay. Very, very important. I hope this is clear. Okay. So we have completed the synopsis. So now let us solve some questions. Okay, we have started last time, few questions we have solved. So let us see the remaining questions now. So very easy chapter, very scoring chapter. Okay, so this is one of the very simple and very easy chapter. So let us see. I think few questions we have seen. Okay. So an element with atomic number 21 is a. So when you write the electronic configuration of atomic number 21, okay. So what it will be? Just see 1s2, 2s2, 2p6, 3s2, 3p, 6, 6, 12, 13, 14, 15, 16, 17, 18. 4s2, 6, 12, 12, 13, 14, 15, 16, 17, 18, 19, 20, and 3d1. Okay. So what it is? The element with atomic number 21. Yes, it belongs to what? It belongs to transition element because D, right? It has entered what? It has entered the D orbital. Right? It has entered the D orbital. Yes, option number A. Very good. Hema has answered it correct. So D block elements, they are also called as a transition element. Okay, this we have seen last time question. Just okay, we'll start again. Next question. The correct order in which the first ionization potential increase is. The correct order in which the first ionization potential increases is. The correct order in which the first ionization potential increases is. Yes, we have seen the ionization potential, how it increases and how it decreases. Yes. Now, if we have this set, okay, so four options are there. Four set of options are there. So if you see the placement of this elements and if you tell me how it varies, firstly, how ionization potential varies across the period. Across the period, what happens to ionization potential and down the group. Down the group and across the period, ionization potential or ionization energy. Across the period, what will happen? It will increase. Okay, across the period, it will increase and down the group, it will decrease. Okay, it will decrease. So this is the trend. Now, when we see the placement, okay, when we see the how it will be, how are the electrons arranged? How are these elements arranged? Yes, try to answer. Very simple question. If you have a periodic table, you please open the periodic table, okay, and just see the placement of this elements. Where is the elements placed? Okay, potassium. First comes your sodium, then comes your potassium. Okay, then where is your beryllium? Okay, if I write I'll write it here. Okay, let me write here. So hydrogen, lithium, then comes your beryllium, then comes your sodium, then your magnesium. Okay, then your potassium. Now again, anything is left? No. Okay, now can you tell me ionization, put this, apply this, how the ionization potential increases? Yes, so you are arranged, right? So first ionization potential increases, how it increases. Okay, now as we move from left to right, so as we move from what? Sodium, first is your potassium. So as you go from top to bottom, okay, it will decrease. Okay, it will decrease and like this will increase. So they have asked the correct order in which the first ionization potential increases. So if I write for beryllium, okay, if I write for beryllium, now if I write the electronic configuration for OR, okay, let me see. So beryllium is 4. So it will be 1s2, 2s2. Okay. Then sodium is 11. So it will be 1s2, 2s2, 2p6 and 3s1. Then is your what? Potassium. Potassium is 19. So it will be, last one will be 4s1. Okay, next, this is 4s1. And your, so this are the four. Now here, if I see the ionization potential, so for to remove these two electrons, it will be maximum. Okay, so it will be more. So energy will be more in this. Okay, so this will be more in beryllium, because as you move across the period, what will happen? It will increases. So this will be highest in beryllium. Okay, in the this will be highest. Then and when you compare of sodium and potassium, as you go down the group, potassium will be less. Okay, so the first ionization of sodium will be more. So here this will be more and this will be less. So if I write the sequence, first will be your potassium. Okay, potassium, and then will be your sodium, and there will be your beryllium. So this is the correct increasing order. So it is option number D. It is option number D. So like this, you have to apply the knowledge of ionization potential. Okay. So ionization potential across a period, it increases, and down the group, it decreases. Now, when you see the electron, okay, removal of electrons, so this is completely filled. It is in duplet state. Okay. So the energy which is required to remove this electrons, it will be very difficult. Okay. So the energy ionization potential will be more in case of beryllium, because across the period it will be highest. Okay. Now when we are comparing sodium and potassium, as you go down the group, it will decrease. Okay, it will decrease. Yes, it will decrease. So when you compare sodium and potassium, sodium ionization potential will be more as compared to potassium. Okay, so first will be your potassium, then will be your sodium, and then will be your beryllium. So beryllium will be highest, then will be sodium, and then will be the less will be potassium. So this, like this, it increases. Okay, so option number D is the answer. I hope this is understood. Okay, let us go for the next one. The correct order of ionization energy of carbon, nitrogen, oxygen, and fluorine is, again, so here the knowledge of ionization energy, okay, the trend followed. So what all you need to know, what is ionization energy, how is the trend followed, okay, how is the trend followed, and what is the placement of elements, okay, placement of elements in the periodic table. So these are knowledge is important, okay. So if you know this, very simple, okay, very simple questions. So just you need to apply this knowledge and crack the question. Okay. Now here, when we see the your periodic table arrangement. Now here, carbon. So carbon is what? Carbon comes in group 14. Okay. Then comes your nitrogen, group 15. Then comes your oxygen, and then comes your fluorine. So this is 14. This is 15. This is 16, and this is 17. So these are the groups. Now, the correct order of ionization energy is, now, ionization energy, we know it is the minimum energy required to remove the electron from an isolated gaseous atom. Trend. Across the period, what will happen to ionization energy? It increases. Okay, it increases. So, which is the trend now? Which will be more? Which will be more? Fluorine will be highest or carbon will be highest? Yes. Which is the answer? Yes, apply. I have told you the placement also. Okay, across the period, it increases. So fluorine will be what? Fluorine will be highest. Okay, fluorine will be the highest ionization energy, and here it will be the lowest. So carbon is less than carbon is less than carbon. Okay, then comes your nitrogen, but then oxygen, and then fluorine. But there is one this. Okay, now when you go for left to right, okay, when you go from left to right, that is from left to right, what is happening? The ionization energy will increase. Okay, but again there is a where we see the electrons. Okay, now here in carbon, the valence electrons are 4, then 5, then 6. Now, when you come to nitrogen and your oxygen, in nitrogen, it is half filled. Okay, it is half filled. So here again, there will be a slight instability. Okay, so because of that, first you will be your carbon, then oxygen, then nitrogen, and then fluorine. Because in nitrogen, if I see nitrogen, it is 7. So it is 1s2, 2s2, and 2p3. Okay. So what you can see, there are 5 electrons. Okay. There are 5 electrons in its outermost shell. So it is what? It is slightly stability is there. Okay. So because of that, the trend which is followed, okay, the correct order of ionization energy is this. Carbon is less than oxygen, which is less than your nitrogen, and which is less than fluorine. So option number C. Okay. Option number C is the correct answer. Okay, let us go for the next one. The oxide of an element whose electronic configuration is 1s2, 2s2, 2p6, and 3s1 is. So, which is the oxide of an element? So, let us see which is this 1s2, 2s2, 2p6, and 3s1, 6, 7, 8, 9, 10, 11. 11 is of which element? It is sodium. Okay, it is sodium element. So, you have to tell which is the oxide which is formed. Oxide means what? When your element sodium, when it uh, uh, when it reacts with oxygen, okay, when it reacts with oxygen, it forms its corresponding oxide. Okay, when sodium, when it reacts with the air or oxygen present, okay, it forms corresponding oxides. Now this oxides, okay, what is the oxide? It is amphoteric in nature. Is it basic in nature? It is acidic in nature, or it is neutral in nature. Amphoteric means what? It acts both as acid and basic. Basic means, yes, it is alkaline in nature. Okay. Acidic means it is acidic pH. Okay. Acidic in nature. And neutral means acting as neutral. Okay. Neutral substance, like that. So you have to tell the oxide of an element whose electronic configuration is. Yes. So it is sodium. When it reacts with oxygen, it forms what it forms? Na plus 1 and oxygen O2 minus. Okay, so it will be what? It will be Na2O. Okay, it will be Na2O. So it is what? It is a alkali metal. Okay, and alkali metals, they are strongly basic in nature. So whenever you have alkali metal, it is the answer is basics. Okay, so they are basic. Alkaline metals are what? They are sodium. It comes under alkali, right? And alkali metals are strongly basic in nature. So option number B. It is okay. It forms sodium oxide and it is basic in nature. So alkali. Okay. So S block elements, they consist of 2 groups, alkali and alkaline. And remember that the oxides of alkali metals are strongly basic in nature. Okay. Yes. So option number B is the answer. Next question. The stability of the order of stability of metal oxide is. So what is the stability of metal oxide? Yes. So see, the different metal oxides are given. Okay, metals, different metals are combining with the oxygen and it is forming the metal oxides. Okay, so you have to tell the correct order of stability. So there are 4 options. Okay. Now here, whenever we are talking about stability of any metal oxide, okay, whenever we are talking about the stability, so here the stability is directly equal to the lattice energy. Okay, it is directly related to lattice energy. And what is lattice energy, students? Anybody knows what is lattice energy? Did you heard about this word, lattice energy? Lattice energy means what? It is the energy which is required, okay, to convert 1 mole of ionic solid, okay, into gaseous substance. into gaseous ions. Okay, into gaseous ions or gaseous substance. So it is that energy. So the energy which is required to convert, okay, to convert 1 mole of ionic solid into gaseous ions. Suppose NaCl solid, I want to convert into NaCl, NaGs, Na plus and Cl minus ions. Okay, so like this. So gaseous ions. So the energy which is required to convert the solid, ionic solid into the gaseous ions. Okay, so that energy is called as the lattice energy. Now, when we are talking about the stability, when we are talking about the stability of metal ions here, so here the metal ions, it is directly related to what? It is related to lattice energy. And our lattice energy, it depends on what? It depends upon the charge. Remember these 2 points. It depends upon the charge and size of ions. Okay. It depends upon the charge and size of ions. So lattice energy, it depends on what? Charge and size of the ions. Now, when we see the charge and size of the ions, okay. So our Fe, so Fe here, okay. So Fe2O3 is less than your chromic oxide, okay, and then your aluminum and MgO. Now, so Fe your Fe2O3. So oxygen is -6. So this is +3. So each oxygen is +3. Then Cr2O3. So this is -6. So this is also +3. Okay, and aluminium Al2O3. So this is +3. And when you see MgO, so MgO is -2. This is +2. Okay, so this is the correct oxide. So when we see the charge and size, so here the order of stability is your option B. Okay, so here it depends on what? Lattice energy, and lattice energy depends on what? It depends on the charge and size of the ions. Okay, so option number B is the answer. Similarly, one more question on the ionization energy. Generally, the first ionization energy increases along a period, but there are some exceptions. One which is not an exception is A, nitrogen and oxygen, B, nitrogen, sodium and magnesium, C, magnesium and aluminium, and D, beryllium and boron. How we are going to apply here now? What is the question asked? The first ionization energy, as we know, it increases, right? Across the period, it increases. But in some of the exception, but there are some exception. Okay, now here, which is not an exception is they've asked. Which is not an exception among the following. So there are 4 options: nitrogen and oxygen, sodium and magnesium, C, magnesium and aluminium, and D, beryllium and boron. Yes. Now, when we see the uh, uh, your elements, okay, how they are placed, let me see. Now, here is our nitrogen, okay. Then comes your oxygen. Nitrogen is our group 15. Then this is your group 16. Then sodium and magnesium, beryllium. Okay, so your hydrogen come first. Then lithium, beryllium. Then your sodium, magnesium. Okay, and in the same row up, here will be your sodium and nitrogen and oxygen. Okay, and boron here beside your group 13. So this is 13, then comes your 14, 15 and 16. So here your carbon, nitrogen comes, okay, and yes. So this is the placement. And when you see aluminum, where is aluminum? Down of boron. Okay, so beryllium I have placed, boron, magnesium is placed, oxygen is there, nitrogen is there. Okay. Now across the period, what happens? It increases, and down the group it decreases. Okay, now which is not an exception among the following is. Now when we see beryllium, okay, when we see beryllium, nitrogen and our magnesium. Okay, so they are having slightly higher values when we compare, when we see the data. Okay, when we see the ionization energy values data, so we see that the beryllium, magnesium, and your nitrogen, they are having slightly value should be higher. Okay, then accepted. This is due to because of their stable configuration. Okay, stable configuration. Because of that, your beryllium and magnesium, okay, they are having fully filled orbitals. And that in case of your nitrogen, it is what? Your p orbitals are half. Okay, because it is 2p3 configuration, right? So p orbitals are halfly filled. So there is a slightly higher stability. So this is the exception. So option number B. So nitrogen and magnesium. Okay. So this is not the exceptional, nitrogen and magnesium. So your beryllium, nitrogen, and oxygen. So these are they are your beryllium, magnesium, and your nitrogen. They are having higher values. Okay, then expected. Why? What is because of the higher stability, stable configuration. Okay, because of the stable configuration. And when you see your beryllium and magnesium, they are uh, fully filled. Okay, when you write the electronic configuration, they are fully filled, 1s2, 2s2, and this is your 13. Okay, so try to write 12. So write and see. So it is completely filled. So because of that, the one which is not an exception is your sodium and magnesium. So sodium and magnesium, when we see, it is not an exception. So it is increasing. Okay, fine. Go for the next one. The correct order of electronegativities of nitrogen, oxygen, fluorine, and phosphorus is. So we know that what happens to electronegativity as you go down the group. Yes, talk about electronegativity now. Electronegativity across down the group, it decreases. Okay, it decreases, and across the period it increases. Now see the placement of these elements. Yes, nitrogen, oxygen, fluorine, here will be of phosphorus. So as you go, what will be the this? So increases. So you have to write the correct order of electronegativities. Okay, so the answer is here. So fluorine will be the least, then will be oxygen, then will be your nitrogen, and then will be your phosphorus. So option number C. Option number C. Okay, so when we write the electronegativity series of these elements, so the correct answer is option number C. So electronegativity decreases down the group and it increases across the period. Okay, along the period it increases. So option number C is the answer. 10th question. Okay, go to the 10th question. For one of the Okay. For one of the element, various successive ionization enthalpies are given below. So which is the element? So your first ionization, so as I've already told you, so ionization energy, okay, what is ionization energy and how the ionization energy increases. For the successive ionization enthalpy, it will be more. So as you see the values, so first 577, then 1810, 2750, 11,580, and 14,000. So as you see, as you are removing next electron, okay, from its gaseous, isolated gaseous atom, you can see the ionization enthalpy is more and more. So which is the element they have asked? A, phosphorus, B, magnesium, C, silicon, and D, aluminium. Okay. Now you can see that in option number this your fourth and fifth ionization enthalpy. Okay, so there is much more difference between this. It is 11,000 and this is 15,000. Okay, so now when you compare the data, okay, and when you compare the elements, now phosphorus, now here when you see between the ionization energy third also, between the third and fourth, okay, what you can see, this is 3,000 and here it is 11,000. So so much jump, right? 3,000 is what value and 12,000 is so much value. So you can see between the third and fourth there is a jump. Okay, there is a higher jump in the values. Okay, means what? Means what it means that I IE4 is much more higher than IE3, right? So means what? The element is having a three valence electron. Okay. So after the third valence electron is removed, when you are removing the fourth, the energy required is much more, right? So the answer is option number D, and that is aluminium. Aluminium is 13. Okay. So that is 1s2, 2s2, 2p6, 3s2, and 6, 7, 8, 9, 10, and 3p3. Okay. So now here, when you are removing first three electrons, the energy is almost same. But when the fourth electron is removed, okay, so energy, you can see there is highest jump. So it is aluminium. Okay. So the element is having three valence electrons. So after the three electrons are removed, when you are removing the fourth valence electron, the energy required is higher. Okay, so ionization enthalpy is highest in this case. So option number D, aluminium. Is it clear? Understood this questions on ionization enthalpy? Yes. Any doubts up to here? Any doubts up to here? So we are trying to solve many such type of questions. Okay, based on ionization enthalpy, because the very important concept, ionization enthalpy is a very important concept. So I have tried to solve much questions on that. Okay. Go for the 16th question. 16th question. The third ionization enthalpy is highest in. The third ionization enthalpy is highest in A. Alkali metals, B. Alkaline earth metals, C. Chalcogens, and D. Pnictogens. So the third, okay, third ionization enthalpy. Now alkali metals, what is the electronic configuration? It is NS1. Okay, alkaline earth metals is NS2. Chalcogens are what? Carbon containing compounds. And pnictogens means your nitrogen compounds. Okay. Now here, when we compare the alkali and alkaline earth metals, okay, alkaline earth metals, it is NS2. So when you are trying to remove the third ionization energy, it will be highest. Okay. So it will be option number B, alkaline earth metals. So NS2, okay, NS2 is the general electronic configuration. So when you are removing the third ionization enthalpy, so at that time it will be highest. Okay. So it is option number B. Option number B. Next one, 17. Amphoteric oxide among the following is A, Ag2O, B, tin oxide, C, beryllium oxide, and D, carbon dioxide. So which is amphoteric in nature? Okay, so remember that your beryllium oxide is the amphoteric in nature. Okay, option number C. So option number C is the answer. Okay, fine. So these were some of the questions. Any doubts up to here? Yes. Fine. So these are some of the questions on this particular chapter, classification of elements and periodicity. So, a few more questions we'll take on periodicity properties in the next class. Okay, so that it will be a good revision for you. So very easy chapter, just the concept should be clear. So if you find some more questions from your side, so please try to solve the questions. Okay. So it will be a good practice for you. So a few more questions we'll be solving in the next class. So based on whatever synopsis, whatever important notes we have studied. Okay. So one more class, one more next class I'll take on classification of elements. And after that, we are going to start with the next chapter, that is chemical bonding and molecular structure. Okay. So fine. So by this, I hope today's class you have understood. Okay, all the important things, whatever I have been told, it is understood by you. Okay. So any doubts from your side? If you have any doubts, you can ask me, or else I will be ending this session here. Fine. Okay. So I hope there are no doubts. Okay. Fine. So by this, I'll end the session here. Okay. We'll meet in the next class. Thank you.